So before we go into the different types of environmental testing, first I want to talk a little bit about the effects that temperature can have on material. Temperature is one of the main parameters in an environmental test, so it's important to understand how temperature can affect your parts. And essentially, it can affect the ductility of material, which can affect the operation at temperature. So typically, materials are going to be a bit more ductile at high temperatures, and they're going to be more brittle at low temperatures. So we can use that temperature testing to see how these materials operate at different temperatures. Also, climate cycling is going to cause expansion and contraction of your parts, and this can lead to stress, especially at material interfaces. If you think about a part that's got different materials within it, you're going to have parts that are expanding and contracting at different rates, and that's going to impose compression and also tensile and shear forces at those component interfaces. And then thermal shock testing involves a rapid change in temperature, and this can create stress cracks on the surface of materials, especially materials with a low thermal conductivity. Oftentimes, you actually can't see these surface cracks with the naked eye, but if you see that image down at the bottom of the screen, that's a magnified image where you can actually see some surface cracks. And over time, those surface cracks will reduce the strength of the material. Also, high temperatures can actually break chemical bonds of polymers. So for instance, you can see polyethylene there at the bottom of the screen. And at a high temperature, you can have a bond break, for instance, between this carbon and hydrogen atom. And when that bond breaks, it actually releases free radicals. And when the free radicals are released, you can actually have branching off of that chain. And that branching eventually is going to cause permanent material embrittlement. And since we talked about the effects of temperature, we also have to touch a bit on the effects of humidity, since this is also a very important parameter in environmental testing. And there are effects of both high and low humidity. On the high humidity side, it can cause corrosion. It can also expose weak seals, especially when it's combined with temperature cycling. So as a part goes through temperature cycling, you're going to have that expanding and contracting that we talked about, which can facilitate moisture movement across seals. So it's important to have a high humidity environment in that case to help expose those weak sealing solutions. And high humidity can also cause electrical faults, such as electrical shorting, and may also reduce the efficacy of adhesives. Now, on the low humidity side, a low humidity environment can facilitate electrostatic discharge. And this is essentially because humidity in the air is going to allow electrons to flow through the air. And so in a low humidity environment, you might run into problems with electrostatic discharge. And also low humidity can cause materials to dry and crack. A good example of this that I'm sure you've all experienced is that image in the bottom right-hand corner, which is a tire which has gone through some pretty extensive dry rotting.